Hello students, hope you are doing well. In this video we are going to discuss services within modular network part 2 of unit 2 structuring and modularizing the network for the subject enterprise network design of B7 semester IT, University of Mumbai. In part 1 of this lecture we have already covered interactive services, security services in the modular network design, internal security, external threat, high availability services in a modular network design. In this part 2 of service within modular network, we discuss voice services in a modular network design, two voice implementation, IP telephony components, modular approach in voice network design, evaluating an existing data infrastructure for voice design, and wireless services in modular network, centralized WLAN components, application networking services in a modular design includes ANS example and ANS components. In this video, we use mind mapping for understanding the concept. Two voice implementation. To ensure successful implementation of voice application network, designers must consider enterprise services and infrastructure and its configuration. For example, to support voice over internet protocol, the underlying IP infrastructure must be functioning and robust. In other words, don't even think of adding voice to a network experiencing other problems such as congestion or network failure. Voice transport is general item that can be divided into two implementation. So these are the two implementation: VoIP, voice over internet protocol, and IP telephony. Voice over internet protocol, it uses voice enabled routers to convert analog voice into IP packets or packetize digital voice channels and route those packets between corresponding locations. Users do not often notice that VoIP is implemented in the network. They use their traditional phones which are connected to a PBX. However, the PBX is not connected to PSTN or any other PBX, but to voice enabled router that is an entry point to voice over internet protocol. Voice enabled routers can also terminate IP phones using session initiation protocol for call control and signaling. IP telephony. For IP telephony, traditional phones are replaced with IP phones. A server for call control and signaling such as Cisco Unified Communication Manager is used, and the IP phones itself perform voice to IP conversion, and no voice enabled routers are required within the enterprise network. However, if a connection to the PSTN is required, a voice-enabled router or other gateway in the enterprise edge is added where calls are forwarded to PSTN. Earlier name for the Cisco Unified Communication Manager includes Cisco Call Manager and Cisco Unified Call Manager. Both implementation require properly designed network. Using a modular approach in a voice transport design is especially important because of the voice sensitivity to delay, the complexity of troubleshooting voice network. All Cisco Enterprise Architecture modules are involved in voice transport design. IP telephony components. There are four components for IP telephony: IP phones, switches with inline power, call processing manager, and voice gateways. Voice gateways. So let us discuss IP phones. IP phones, these are IP phones, are used to place calls in the IP telephony network. They perform voice to IP and vice versa coding and compression using special hardware. IP phones offer services such as user directory lookup and internet access. The phones are active network devices that require power to operate. Power is supplied through LAN connection using PoE or with external power supply. Second is switches with inline power. Switches with inline power, that is PoE, enable the modular wiring closet infrastructure to provide centralized power for Cisco IP telephony network. These switches are similar to traditional switches with an added option to provide power to the LAN ports where IP phones are connected. The switches also perform some basic quality of services tasks such as packet classification, which is required for packetizing voice through network. Next component is call processing manager. Call processing manager such as Cisco Unified Communication Manager provides central call control and configuration management for IP phones. Okay, and it provides the core functionality to initialize IP telephony devices and to perform call setup and call routing throughout the network. Cisco Unified Communication Manager can be clustered to provide a distributed, scalable, and highly available IP telephony channel model, and adding more servers to a cluster of servers provide more capacity to the system. Next is voice gateway. This is also called voice enabled routers or voice enabled switches. Provide voice services such as voice to IP coding and compression, PSTN access, IP packet routing, backup call processing, and voice services. Backup call processing allows voice gateway to take over call processing in case the primary call processing manager fails. Okay. Voice gateway typically supports a subset of the call processing functionality supported by the Cisco Unified Communication Manager. Other components of an IP telephony network includes a robust IP network, voice messaging and application, and digital signal processor resources to process voice functions in hardware, which is much faster than doing in software. So there are some components in this IP telephony network. Here, call processing engine, Cisco Unified Communication Manager, IP phones and endpoint, PSTN gateway router, router or gateway, PSTN IP WAN, QoS enabled WAN infrastructure, DSP resources, digital signal processing resources for conferencing, voicemail, voice message and application. So these complete thing creates the infrastructure for IP telephony. Modular approach in voice network design. Implementing voice requires deploying delay-sensitive services from end to end in all enterprise network modules. Use the modular approach to simplify design, implementation, and especially troubleshooting. Voice implementation requires some modification to the existing enterprise network infrastructure in terms of performance, capacity, and availability. Because it is an end-to-end solution. For example, clients, that is IP phones, are located in building access layer and the call processing manager is located in the server farm module. Therefore, all modules in the enterprise network are involved in voice processing and must be adequately considered. Voice affects the various modules of network. These are building access layer, building distribution layer, campus core layer, server farm module, and enterprise edge. So in case of building access layer, IP phones and end user computers are attached to layer 2 switches here. Switches provide power to the IP phones and provide quality of service packet classification and marking, which is and essential for proper voice packet manipulation through the network. So these are the things associated with building access layer. Now come to building distribution layer. This layer perform packet reclassification. If the building access layer is unable to classify packet or not within the trusted boundary, it aggregates building access layer switches, wiring closet, and provide redundant uplink to the campus core layer. So it provides the uplink to campus core layer. Then come to campus core layer. The campus core layer forms the network's core. Okay, and all enterprise network modules are attached to it. Therefore, virtually all traffic between application servers and client traverse the campus core. With the advent of wire speed multi-layer gigabit switch device, LAN backbones have migrated to switch gigabit architecture that combine all the benefits of routing with wire speed packet forwarding. Then server farm module. So this module includes multi-layer switches and redundant connections to redundant Cisco Unified Communication Manager, which are essential for providing high availability and reliability. Then come to Enterprise Edge. The Enterprise Edge extends IP telephony from the enterprise campus to remote location via WAN, the PSTN, and the Internet. The figure attached here give voice transport example. It is the voice network solution in the Cisco Enterprise architecture. It illustrates how a call initiates on IP phone and how the call setup goes through the Cisco Unified Communication Manager and how the end-to-end session between two IP phones is established. Note that Cisco Unified Communication Manager is involved only in the call setup. Calls destined for remote location traverse the enterprise edge through WAN and MAN and site-to-site VPN module or through the remote access and VPN module. Call destined for public phone numbers on PSTN are routed over the enterprise edge through the remote access and VPN module. Calls between IP phone traverse the building access, building distribution, and campus core layer, and server farm module. Although call setup uses all these modules, speech employ only the building access, building distribution, and in some cases, the campus core layer. So here you can see initially we start with here and this go to number 2 dialing plan Cisco Unified Communication Manager and again come back to this multi-layer switch, jump to multi-layer switch and then back to switches. So IP phone to phone session, this is the way how we can establish the connection and we can go for communication. Now one question may arise, how do we evaluate existing data infrastructure for voice design? When designing IP telephony, designers must document and evaluate existing data infrastructure in each enterprise module to help determine upgrade requirements. For this purpose, we evaluate using performance measurement, enhance infrastructure for additional bandwidth, consistent performance, or higher availability, if required, might be necessary for the converging environment. Performance evaluation include analyzing network maps, device inventory information, and the network baseline information. Links and devices such as those with high peak or busy hour use might have been upgraded to provide sufficient capacity for additional voice traffic. Devices with high CPU use, high backplane use, high memory use, queuing drops, or buffer misses might have to be upgraded. Then come to availability. This is very important thing. Redundancy in all network modules should be reviewed to ensure that the network can meet the recommended IP telephony availability goals with the current or new network design. Then come to features like chassis module and software version. So examining and the router and switch characteristic, including the chassis module and software version to determine the IP telephony features capabilities in the existing environment. Then come to capacity. Evaluate overall network capacity in the and the impact of IP telephony on the module by module basis to ensure that network meet capacity requirement and that there is no adverse impact on existing network and application requirement. So this is done module by module. Then power. So without power, we won't be able to do anything. Assesses the power requirement of the new network infrastructure, ensuring that additional devices will not overscribe existing power. Consider taking advantage of PoE capabilities in the devices. Wireless services in a modular network. A wireless LAN or WLAN supports mobile clients connecting to the enterprise network. The mobile clients do not have a physical connection to network because WLAN replaces the layer 1 traditional wired network, usually category 5 cable with radio frequency transmission through the air. Wireless LAN are for local network either in building, line of sight, outdoor bridging application or combination of all these. So in a wireless network may issue there many issues can arise to prevent the RF signal from reaching all parts in the facility, including multiple distortion, hidden node problem, interference from other wireless sources. Near for issues, a site survey helps find the regions where these issues occur by defining the contours of radio frequency coverage in a particular facility, discovering regions where multi-part distortion can occur, areas where RF inferences is high, and finding solution to eliminate such issues. Privacy and security issue must also be considered in a wireless network because WLANs are typically connected to wired network. All the modules within the enterprise infrastructure must be considered to ensure the success of wireless deployment. So here we can see there are several things associated with this. So there are centralized WLAN components. So in this particular figure, we have used the centralized WLAN components or wireless LAN components. The four main components includes end user devices, wireless APs or access points, WLC, WLAN controller, existing switch and routed wired network. So in this particular building, you can see where it is included and where it is placed. So let us start. End user devices. End user devices are simply your laptops or mobile. A PC or other end user devices in access layer use a wireless NICs to connect to an access point using radio waves. Okay, so here NICs are there, network interface card. Through this we can connect. Then come to wireless access point. So access points typically in the access layer are shared devices that function similar to hub. Okay, so these are the functioning of this is very similar to hub. Cisco APs can be either lightweight or autonomous. So this is very important that these are autonomous or lightweight. Fine. Lightweight access points are used in centralized WLAN deployment. A lightweight access point receives control and configuration from a WLAN controller, that is WC, with which it is associated, providing a centralized point of management and reducing the security concern of stolen access points. An autonomous access point has a local configuration and requires local management, which might make consistent configuration difficult and add to the cost of network management. Now come to WLC, Wireless LAN Controller. It provides management and support for wireless services such as roaming. The WLC is typically in the core layer of enterprise network. So this is WLC for roaming environment of the devices. Then existing switches and routed wired network. So it is located here. The wireless access point connects to the application networking services in a modular network design. Traditional network handled static web pages, email, and routine client server traffic. Today, enterprise network must handle more sophisticated type of network application that includes voice and video. Example includes voice transport, video conferencing, online training, and audio and video broadcast. Application place increasing demand on IT infrastructure as they evolve into high visibility services that represent the face of the business to internal and external audience. The large amount and variety of data requires that the modern network be application aware. In other words, be aware of content carried across it to optimally handle that content. It is no longer enough simply to add more bandwidth as needed as needs grow. Networks have had to become smarter. A new role is emerging for the network as provider of network uh, application infrastructure services that extend the value of application either by improving delivery of content to users and other applications or by offloading infrastructure functions that today burden deployment and development and operation teams. Application networking services, that is ANS, provide this intelligence. So let us see the example of application deployment issues and solutions. In this particular case, there are sample deployment issues and sample ANS solution. Consolidation of data centers result in remote employee having slower access to centrally managed application. So solution is wide area application services in branch office that compress cache and optimize content for remote users so that they experience LAN-like responsiveness. A new web-based ordering system experiences a high proportion of abandoned order, okay, because of poor responsiveness during the checkout process. For this purpose, optimization of web streams being sent to an e-commerce portal, which reduces latency, suppresses unnecessary reloading of web objects, and offloads low-level tasks from the web server. This is not the concern for today's generation, but when we started this type of services, it was the major concern. Business partners need immediate and secure electronic access to information held in back office application such as shipment information, security and remote connectivity services that automatically validate a partner's request, route it to the appropriate back office application and encrypt and prioritize the response. Last, the purchase application needs to log and track orders over a certain value for compliance purpose. Okay, for this purpose, the solution application messaging service that intercepts purchase order, locates the value and logs large order to database according to business policy rules. So these are the things how we can handle application networking services in a modular network design. So let us now discuss ANS components. There may be question in your examination like uh, discuss different ANS components. So in this particular figure, we are able to see the example of ANS deployed in office, connected over a wide area network, providing LAN-like performance to users in the branch, regional, and remote offices. Okay, these are the different offices, and this is the WAN. Fine. ANS components are deployed systematically and symmetrically in the data center and the distant offices. The ANS components in this particular example is Cisco Wide Area Application Service. Okay, first thing is Cisco Wide Area Application Services, WAAS software. Cisco WAS software gives remote office LAN-like access to centrally hosted application servers, storage, and multimedia. These are the accesses. Okay. Next is Cisco Wide Area Application Engine, WAE. Cisco Wide Area Application appliances provide high performance global LAN-like access to enterprise application and data. WAE is used either WAS or application and content networking system, ACNS. Okay, ACNS software. WAEs help consolidating storage, server, and so forth in the corporate data center with only low cost, easy to maintain network appliances in distant offices. So this is one more thing, that is Cisco Wide Area Application Engine. So this is the place Cisco Wide Area Application Engine is located. Now come to Cisco 2600, 3600, 3700 content engine module. So this engine module is located, okay, wide area application engine appliances, content engine network module, and Cisco WAS central manager, primary or standby. So these are the things, and different offices are there. You need not go for drawing the offices, just go for draw the design how it is located. So this component content engine module can be deployed in the data center or branch office to optimize WAN bandwidth, accelerate deployment of mission critical web application, add web content security, and deliver live and on demand business video. So this is how we can use or deploy the ANS components. Okay. Now to conclude this chapter, services within modular network part 2, we have completed voice services in modular network design, wireless services in modular network, and application networking services in modular network design, that is ANS. So here we have seen the ANS examples and different components, the question associated with this. In wireless services in modular network, centralized WLAN components. Then voice services in modular network design, two voice implementation, VoIP and IP telephony. Okay. IP telephony components, modular approach in voice network design, and evaluating the existing data infrastructure for voice design. So this concludes this topic, services within modular networks. In next video, we will see network management protocol and its feature part 1. Thank you very much. Bye bye.